Question number 14. A 1.2 meter tall girl spots balloon moving with the wind in a horizontal line at a height of 88.2 meter from the ground level. The angle of elevation of the balloon from the eyes of the girl at any instant is 60 degree. After some time, the angle of elevation reduces to 30 degree. Okay, find the distance travelled by the balloon during the interval. It's very important question, children, and figure is given in the question. So children, even if the figure is not given, you can easily draw the figure, because the ground level, a girl of height 1.2, and from this point, that is from her eyes, that she is watching the balloon, okay, at an angle of 60 degree. Okay, and she is not moving from her position, okay, because of the wind, okay, that balloon get displaced, okay, from this position to that position, okay, and maintaining that height, that is 88.2 meter. Okay, so same distance, same height. So that the distance travelled by the balloon during this interval, okay, that means from this position to this position, that is what is asked in the question. So you will find the distance travelled by the balloon during the interval, that is the question. It is clear, children? Okay. So first of all, we can name these points, that is here A, starting point A, B, C, D and E. See, here this horizontal level, that is the first side, is parallel to the ground, okay, and here it makes 90 degree, that is that height, and the ground will make the height of the balloon perpendicular distance, that is actually height. Okay, so this is also 90 degree, and here also 90 degree, so that you can consider two right triangles. Okay, that is right triangle, here ACB and ADE. And here this balloon is maintaining the same height, that is 88.2 from the ground level. But here this portion, this is the part of the side of the right triangle, that means this length should be subtracted, and that length is equal to the height of the girl. That means here actually ED is equal to 88.2 minus 1.2, that is 87 meter. And that is equal to ED equal to BC, that is perpendicular distance. So BC equal to ED equal to 87. Understood? Okay, and here the angle of elevation, that is given from this point. Here the girl is not moving from her position, okay, and the first side, that is angle of elevation, that is given as 60 degree. Okay, so we can consider here the right triangle ACB, okay, and you can take that measure as angle as acute angle as 60 degree. Okay, so consider triangle ACB, okay, tan of 60 degree equal to BC by its adjacent side, that is AC, okay, and the value of tan 60 is root 3 equal to BC is equal to ED, that we have seen that 87 divided by AC, okay, so AC equal to 87 by root 3 by cross multiplication, okay, by root 3 meter. See, from the figure, children, see here CD is equal to here BE, because this is the distance travelled BE. If you join these points, BE is parallel to the CD. Okay, so here in terms of CD, you can write ADCD equal to, in terms of the two sides of the right triangle, that is the big, from the big right triangle AD, if you subtract this AC, this portion from AD, that is the total length, okay, you will be getting that CD, and that CD is the distance travelled by the balloon during this interval. Okay, so that is the idea of this question, children. So we are converting everything in terms of the sides of the right triangle, and we can relate that. Okay, and from the figure, this CD is the distance travelled because of this BE, and that is equal to AD minus AC. Okay, so for that we have now AC is here from by taking right triangle ACB. The second case I am going to take the second right triangle. So consider triangle ADE tan of 30 degrees. For the second triangle, that acute angle, okay, the angle of elevation from this point to that balloon, okay, because of the wind, the balloon is at present this place, okay, so at E, so angle of elevation is 30 degrees, so tan 30 degree equal to ED by AD, that big triangle. So this is the side of that adjacent side. So 1 by root 3, the value of tan 30 equal to ED is given as 87 divided by AD. Okay, so you will have AD by cross multiplication, AD equal to 87 root 3. Okay, and in order to get CD, what we have to do? You can substitute in this equation. Okay, so distance travelled by the balloon. Distance travelled by the balloon equal to CD, and we have seen that that is equal to AD minus AC. Okay, see from this we have 87 root 3. 87 root 3 is AD minus 87 by root 3, that is for AC, 87 by root 3. So from these two terms 87 can be taken outside. So you will have 87 into root 3 minus 1 by root 3 is there in the second term. 87 from the numerator we have taken outside. Okay, so you can cross multiply. So 87 into root 3 3 minus 1 divided by root 3. That means 87 into 2, 3 minus 1 divided by root 3. Since root 3 is an irrational number, you have to rationalize by multiplying and dividing with root 3 by root 3. And root 3, sorry. So root 3 and root 3 become 3. Okay, so that will be in the next step, that is CD, the distance travelled by the balloon, CD equal to 87 into 2 into root 3 divided by 3. Root 3 into root 3 is 3. Okay, so we can divide because here multiple of 3, this 87. So 3 in 8, 2 times, and in 27, 9 times. Okay, and 29 into 2 is 58 root 3 meter. This is the distance travelled by the balloon. Okay, now the next question. Now we have the 15th question. This is the most important question. I will tell you children, we can expect one question from this video, definitely for the board examination. Okay, so the question is, a straight highway leads to the foot of a tower. A man standing at the top of the tower observes a car at an angle of depression of 30 degree, which is approaching the foot of the tower at a uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degree. Find the time taken by the car to reach the foot of the tower from this point. So children, here we have a straight highway approaching to the tower, and a man is standing upon the tower and observes a car which is approaching to the tower. Okay, so initially observes the car at an angle of depression 30 degrees. So at this point the height of the man is not given. So from this point, this is the line, first side, that is the horizontal level, and as he lower his head to watch this car, okay, this is the highway, okay, highway, okay, so this is the 30 degree, so this angle also 30 degree, okay, and the car is moving with a uniform speed, and 6 seconds later the angle of depression of the car is found to be 60 degree. That means after 6 seconds that car is more close to the tower. Okay, so angle of depression also changes, that is 60 degree Okay, so from this line of sight and the horizontal, it makes 60 degree. So here also, because of alternate interior angles are equal, this angle also 60 degree, 60 degree. Okay, we have to convert these measurements in terms of here by taking that angle of elevation equal to angle of depression, because alternate interior angles are equal for parallel lines. Okay, and what is asked, children? Find the time taken by the car to reach the foot of the tower. Okay, from this point to this point, what is the time taken? That is what is asked. Okay, and for that, in all the time that the car is maintaining a uniform speed, that is very important. Here the distance, nothing is given. The only clue what is given as these angles of depression and also the distance from the time taken from this point to this point, that is 6 seconds. And the no other height of the tower, nothing is given, children. So first of all, we can name these points A, B, C and D. Okay, and from this figure also, you can make, we can see that this angle is 90 degree. This tower and the ground level make 90 degree. Okay, so we can see two right triangles and AB is the common side. So we can form two equations with respect to AB. Okay, and from that you can easily get that answer. Okay, so first of all, I am considering the right triangle ABC. Okay, so consider right triangle ABC, which is acute angle, that is 60 degree. So tan of 60 degree. Okay, so tan of 60 degree equal to AB by BC. Okay, that is root 3 equal to AB, that height is not given. So AB by BC, and since AB is a common side, I am going to write this expression with respect to AB, that is BC into root 3 or root 3 BC. This can be equation number 1. And for the second equation, I am considering the second triangle, that is right triangle ABD. Okay. Right triangle ABD, in right triangle ABD, that acute angle is 30 degree. Okay, so tan of 30 degree, because we need these two ideas. So tan, the ratio is tan. So AB divided by BD. Okay, and tan 30 value is 1 by root 3 equal to AB by BD. And from this I am writing with respect to AB, that is BAB equal to, okay, by taking this, that is AB is equal to BD by root 3. Now we can mark this as equation number 2. So now see these two equations, these both are with respect to AB. That means you can equate this RHS part of both the equations. That means root 3 BC or BC root 3 from 1 and 2, from equation 1 and 2, you can equate it their RHS part, that is BC into root 3 equal to, the RHS part is BD by root 3, BD by root 3. Okay, I am taking this root 3 to LHS, so multiplication root 3 into root 3 is 3. So 3 times BC, this BC equal to 3 BD. Now see, not 3 BD, simply BD. Sorry children, so BD, because we have taken root 3 to this side, so only BD is allowed. So 3 BC equal to BD. Okay, see from D to C, that car takes 6 seconds. That is given in the question. Okay, that means here after 6 seconds. Okay, the angle of depression. So from D to C, that is 6 seconds. Okay, so I am expressing this BD, the total distance, with respect to CD or DC, because we need the time taken from this point to the foot of the tower. Okay, that means BC. Okay, so from in terms of CD, from the figure, that is equal to BD minus BC. BD minus BC. Okay, and here children, BD we have given as 3 BC. By comparing equation 1 and 2, you got 3 BC equal to BD. So I am going to substitute here BD as 3 BC. And I am keeping this BC as it is, and now you have 3 BC minus BC is 2BC. Okay, that means you got here CD equal to 2BC. That means from D to C, this distance. Okay, or here you will be getting CD by 2 equal to BC, because we need the time taken from this point to this point, BC. So BC is actually the half of the distance of the CD. Okay, and since the car is moving in a uniform speed, okay, that means if it takes 6 seconds to cover this distance CD, and being that BC is half of CD, that is what we got now here, children. That is BC equal to half of CD. Okay, that means for traveling the distance CD, it takes 6 seconds, which means for traveling from this point to this point, that is BC, it takes its half. Okay, if it takes here, the distance is 10 kilometer, so and the distance will be, that BC will be 5 kilometer, and the time will be the half of it. Okay, that means here the time taken is 6 by 2, that is 3 seconds. 6 seconds divided by 2, because here this is very important expression. Okay, just comparing first and second equation, we have 3BC equal to BD. Okay, and since we need BC, okay, and you can and also CD, it is given in terms of CD, the distance, and the time taken is given as 6 seconds for CD. So I have expressed this in terms of CD equal to BD by BC, and BD is 3BC and 2BC is here, and we can see that BC is equal to CD by 2. Okay, so that since the car is moving in a uniform speed, the time will be half of it. That is 6 divided by 2 is 3 seconds. It is clear, children? So the same problem can be done using this speed equal to distance by time. That way also okay, but I think this would be the better way. You can easily get into the answer. The only thing is here you should know BC is the distance, BC is half of the distance CD, that much only. Okay, now we are moving to the next question. Now the last question. The angle of elevation of the top of a tower from 2 points at a distance of 4 meter and 9 meter from the base of the tower and in the same straight line are complementary. Prove that the height of the tower is 6 meter. That means we have a tower, okay, and 2 points should be marked in the same straight line, okay, and from this point and this point, okay, this distance is 4 meter, and from this point to the foot of the tower is 9 meter. And the angle of elevation, okay, and what is this very important question, children. The angle of elevation of the top of the tower from 2 points at a distance of 4 meter and 9 meter, okay, and in the same straight line with it are complementary. That measurements are not given. The only clue is these two angles make that the angle of elevation of the top of the tower from these 2 points, okay, are complementary. Complementary, when two angles are said to be complementary, when their sum of two angles are equal to 90 degree. So if this angle is theta, this will be 90 minus theta. Okay, that means theta plus 90 minus theta equal to 90 degree. That is the meaning. If you are taking this as theta, this angle will be 90 minus theta. Okay, and what we have to find out, the height of the tower, we have to prove that that is equal to 6 meter. It's a proof. Okay, height of the tower here represents, AB represents the height of the tower. Okay, let AB represents the height of the tower. So as usual, this tower and this line make 90 degrees. So you can apply take 2 right triangles, and we can take tan of that ratio, so that you can easily reach into the answer. Okay, let us see, children. Consider right triangle ABC. Okay, we have tan of acute angle is 90 minus theta equal to opposite side AB by BC. Okay, so tan of 90 minus theta, we can't substitute its value. Okay, we know only that some specific angle, that is 30, 45, 60, that's all. So AB is the required, we have to prove that that is equal to 6 meter divided by BC is given as 4. So, okay, so let it, so and also here AB is common side, children. For both triangles you can see AB is a common side. So we can express both equation with respect to AB. Okay, so here you can take 4 times or we can let it be like this. Okay, so this is equal to equation number 1. And the second equation I am considering. So tan of 90 minus theta equal to, so tan of 90 minus theta equal to AB by 4. Okay, let it be equation number 1. And the second equation we can consider right triangle ABD, its acute angle is theta. So tan theta equal to opposite side AB by BD, and BD is given as 9. Okay, BD. So tan theta equal to AB by BD is 9. This can be equation number 2. See children, here in this equation, what we have to prove? We have to prove that this AB equal to 6 centimeter. How can we eliminate tan of 90 minus theta and tan theta from these two equations? Nothing else is not given, children. No other details are given. So this is a very typical question. So if you have this type of angles complementary, see tan of 90 minus theta, we know that in the complementary relation we have learned that tan of 90 minus theta is cot theta. Okay, so from this you can write from equation 1, okay, tan of 90 minus theta is equal to cot theta equal to AB by 4. Okay, and cot theta and tan theta, these two ratios are not there in the question. That is, we have to prove that AB equal to 6. That means we have to eliminate all this. Okay, and for that, how can we eliminate tan theta and cot theta? Since the tan theta or the cot theta are the reciprocal relation, okay, and the product of a ratio with its reciprocal is 1, that can be easily eliminated when you multiply these two equations. Okay, so let it be equation number 3, or this can be renamed as equation number 1. Okay. Now we are multiplying equation 1 into 2. Then only this tan theta and cot theta get eliminated. That is not needed. We have to prove that height of the tower is 6. Okay. So in order to eliminate, we have to multiply equation 1 and 2. That means multiplication means multiply LHS and RHS part separately of both the equation. So LHS of first equation cot theta and LHS of second equation is tan theta equal to AB by 4 into RHS of second equation AB by 9. And tan theta into cot theta 1 equal to AB into AB square by 4 9s are 36, or AB square equal to 36. In order to get AB, you have to take the square root plus or minus 6. Being here it is the height of the building, we can consider only the positive value, so 6 meter. That means now we have seen that the height of the tower is 6 meters. This is very important problem, children. So we have completed all the 16 problems of exercise 9.1. Okay, see children, even if this question, some questions are little bit lengthy, so you should take sufficient practice so that whatever the problems comes under this lesson, you can easily solve it for the examination. Okay, so thank you children, thank you for watching and supporting my channel. Thank you all.